Ever find yourself writing the same piece of code over and over and over again? Well, you're not alone. Today, we're going to dive into one of the most powerful tools a programmer has to absolutely crush that kind of repetition: JavaScript loops. Let's jump right in. So, here's what we're going to cover. First, we'll talk about why loops are so important. Then, we'll meet the two big workhorses, the while and for loops. After that, we'll check out a more specialized tool, the do-while loop, and learn how to get precise control with break and continue. And finally, we'll really level up our skills with something called nested loops. All right, so first things first, why even bother with loops? Well, honestly, they were invented to solve one of the most annoying problems in all of programming, just plain, tedious, mind-numbing repetition. I mean, seriously, just think about that for a second. You need to add up 1,000 numbers. Are you really going to sit there and type sum equals sum plus number 1,000 times? No way. Your fingers would cramp up, your code would be a mile long, and if you made one mistake, good luck finding it. There has to be a better way, and, of course, there is. And that better way is the loop. You can think of a loop as a little robot that you build right into your code. You just give it a job to do and a simple rule for when to stop, and it just goes. It'll do that one task over and over and over until the condition you gave it is no longer true. And, no matter how complicated they look, every single loop boils down to this super simple three-part dance. First, it asks the question, the condition. Like, hey, is our counter variable I still less than 1,000? If the answer is yes, it moves on to step 2 and performs the action in its body. And then, step 3, it just zips right back to the top to ask the question all over again. Condition, body, repeat. That's the magic. Okay, so now that we know why we need loops, let's meet the how. In the world of JavaScript, you're going to be spending most of your time with two main types, the while loop and the for loop. These are the real workhorses. First up, we've got the while loop. And honestly, its logic is pretty much right there in the name. It's as simple as it sounds. The loop just keeps running its code over and over while some condition you set is true. It's fantastic for situations where you don't know exactly how many times you'll need to loop. You just know what you're waiting for. Now, its cousin, the for loop, is often the go-to choice when you know ahead of time exactly how many repetitions you need. What makes it so great is how organized it is. It bundles everything you need to control the loop, where the counter starts, the condition to stop, and how to update the counter each time, all into one neat little package. This little bit of organization is a lifesaver, trust me. It helps you avoid one of the most classic coding nightmares, the infinite loop, where you forget to update your counter. And check this out. This comparison really says it all. We're doing the exact same job here, summing numbers. Look at the while loop on the left. It works, sure. But notice how you have to set up your variable before the loop, and then you have to remember to increment it inside the loop. It's easy to forget that last part. Now look at the for loop on the right. Bam! It's all right there in one clean, readable line. It's not just prettier, it's safer and less prone to errors. All right, let's talk about a more specialized tool. This is the loop you pull out of your toolbox for one very specific situation, when you need to guarantee that your code runs at least once. And that tool is the do-while loop. Now, unlike the other two, which check the condition before they do anything, this one is the act first, ask questions later loop. It runs the code inside its body one time, no matter what. Then it checks the condition to see if it should go again. The perfect example is asking a user for a password. You have to ask for the password at least once before you can even check if it's the right one, right? That's a job for do-while. Okay, so you've got your loop running, but what if you need to be a bit pickier? What if you need to bail out early, or maybe just skip over one specific item? Well, for that, you have break and continue. Think of break as the big red emergency stop button. The second your code hits that break keyword, it's game over for the loop. It doesn't ask any more questions, it doesn't finish the current run, it just stops dead in its tracks, and the program continues on with whatever comes after the loop. Now, continue is a little different. It's not a sledgehammer, it's more like a scalpel. To see what I mean, let's imagine we're in a loop that's just printing out numbers from -5 all the way up to +5. Pretty straightforward, right? You get the list you see here. But what if, for some reason, we wanted to ignore the number 0? Okay, now watch this. We add one tiny little rule inside our loop. If our number is 0, continue. And boom, take a look. Where's the 0? It's gone. See, continue doesn't kill the whole loop. It just says, hey, for this one specific run, we're done. Skip everything else and just jump back to the top to start the next iteration. It's perfect for filtering things out. All right, you've mastered the basics. Now it's time to go to the next level and unlock a whole new dimension of power by putting loops inside of other loops. This is where you can start solving some really complex problems. A nested loop is exactly what it sounds like, a loop that lives inside the body of another one. And this multiplication table is the perfect way to picture it. Just think of the outer loop as controlling the rows. That's our variable I. For every single time that outer loop runs, the inner loop, j, runs its entire course, handling all the columns. This is how you start working with grids, 2D arrays, and all sorts of complex data structures. But, and this is a big but, there's a classic trap that gets almost everyone at first. If you use a break statement inside that inner loop, it only breaks out of the inner loop. The outer loop doesn't even know what happens. It just shrugs, finishes its current run, and keeps on chugging along to the next one, which can cause some really confusing bugs if you're not ready for it. So how do you fix this? Well, JavaScript has this really cool, kind of hidden feature, a labeled break. You can actually give your outer loop a name, a label. Then, when you call break, you can tell it the name of the loop you want to escape from. It gives you this pinpoint control to just blast out of multiple layers of loops all at once. It's super powerful. So, with all of these options, how on earth do you choose the right one? Well, it's actually pretty simple, and this is your cheat sheet. If you know exactly how many times you need to run, 100 times, 1,000 times, go with the for loop. It's built for that. If you're looping until something changes, like until a user clicks a button, a while loop is your friend. And if you have that one special case where you absolutely must run the code once before you even check the condition, that is a job for do while. And there you have it. That's our tour of JavaScript loops. You've gone from the simple why all the way to controlling complex nested structures. You now have the fundamental building blocks of automation at your fingertips. So I guess the only question left is, what are you going to build? What tedious task in your own code can you now replace with a few elegant lines of a loop? That's the power you now have. Thanks for watching.